Hi everybody. In the program it says I'm talking about extreme connectivity, which I was until I got on the train when I started thinking more closely about what I was actually going to talk about. And I realized that what I wanted to talk about was smart people and dumb objects, because I think there's often this confusion that arises from thinking that the smartphone is itself smart, or that the smart device or the smart home or the smart city or even the smart planet, somehow the smartness resides within some kind of physical fabric. And I think that actually where the smartness resides is in the people and the capacity to enable people to be smart with things. And so what I'm going to do is I'm going to give a really brief introduction to some of the work I've done in the past. I'm going to then talk very specifically about something I've been engaged in basically for the last 3 years, actually 6 years from inception, which is called patchbay, which is basically a data broker for sensor, energy, and environmental data. And I'm going to wrap it up with just an example of the kind of thing that you can build, or the kinds of things that you can build to such a system. As Imran explained, my background is in architecture. And basically for the last 12 years, I've run a design practice, which has basically been centered around the idea of enabling people to take ownership, to create, to design, to interact with their spaces. And it's ranged from projects like the reconfigurable house, which is basically a prototype home packed with thousands of sensors and actuators that are actually hacked from inexpensive toys, basically the sort of £1 toys that you can get from Chinatown. And the purpose of that was to show that people themselves, A, can build a sort of massively wired up home themselves, but B, they can actually configure it themselves. So it's not about this sort of closed package of the smart home. It's more about enabling people to design their own environments. Then there are projects like the Burble, which is sort of 15-story structure that's assembled and controlled by members of the public. They're the ones who design it, and they're also the ones who bring it to life. This is the balloon structure down there. Now, along the way, I found the need to develop basically a kind of a back-end infrastructure for managing the data from lots of the sensors that were involved in building these projects. And I built it for myself about 6 years ago, and eventually friends and colleagues wanted to use it. And so about 3 years ago, I spun off this company, which is called Connected Environments. And our core product, or the sort of core thing we do, in fact, the only thing that we're known for is a web-based data brokerage, which is called patchbay. And the reason we call it patchbay, despite the funny spelling, which confuses people and makes them wonder actually what it is and how to pronounce it, the reason we call it patchbay is because the idea is to be able to patch anything into anything else. You know, the old idea of the sort of switchboard, to be able to plug in a microcontroller that can communicate with a building management system, that can connect to a biosensor that's talking somehow with a sort of an interoperable language with an environmental monitor to connect to some kind of building automation system. Because the way these kind of machine-to-machine communication systems have been built in the past is based on the sort of industry vertical, the closed silo. You know, if you're dealing with home automation, then the only things that's ever going to talk to, those devices are only going to talk to the home automation products. And what we're essentially trying to do is build horizontal systems. And that's what patchbay is actually all about. I'm trying to learn from the things that have really driven growth in Web 2.0 and things like Twitter and Facebook and YouTube, the capacity to share across multiple disciplines, because that's actually where innovation comes from. I don't actually know exactly why the logistics industry might want to talk to the home automation industry, that might want to talk to the home healthcare industry, that might want to talk to the weather stations or the environmental monitoring, but I suspect that somebody will be able to come up with incredibly useful applications if those industries, if those products and services and things that are built with it are able to communicate in real time. And so that's actually the real challenge that we're trying to answer with patchbay, which is, it's a little bit like Twitter, in that what we're trying to do is build the back end to enable communication so that other people can start to build all the applications that other people can actually start to innovate on top of the platform. And so essentially, just to summarize exactly what patchbay does, on the one hand, it enables both storing and sharing state and context data. I actually think that the context data is the most important part. It's not really the real-time values that are so important. It's not so important to know that this sensor is 21 degrees Celsius. It's important to know that this one's 21, this one's 23, that this one's an internal reading, this one's an external reading. This is actually tagged by the user as an embarrassment measure, or, you know, and this one's tagged as a refrigeration unit or whatever. So it's the metadata that really gives value to this kind of data. But out of the box, the default mode for patchbay is that it makes it possible to share that data. So rather than making a closed system and then trying to open up parts of it, we've built a completely open system, recognizing that some people will want to close off. There will be data that people want to make private. So there is that possibility. But the default mode is to be able to share it in real time, but also historical data. So having built this massively scalable and highly available system, all we really need to do when we have these new devices that want to connect to it, when you as sort of end users or producers really want to connect things to it, is just develop new protocol adapters, basically. Because out of the box, we support many different protocols and adapters, but it becomes fairly easy to build something new to translate for it, now that we've got this sort of massive database that's capable of handling millions of data points per day. What we're doing is, of course, trying to store all of the data, not just summary data, so that who knows why you might want to know the temperature 15 years ago. Actually, now we realize that we wish we'd had this sort of high-resolution temperature readings over the last 15, 20 years. Perhaps the same will be for energy consumption. On top of that, it's also possible to add your own metadata. And here we're kind of learning from Flickr machine tags, triple tags, these kinds of things, where users, or rather I like to call them producers in the system, are actually able to use their own ontologies, their own ways of describing what their feeds are, what their devices are, things like that. And the point here is that, without wanting to get into a debate exactly about what linked data or the semantic web is or what have you, this is at least a good stepping stone towards something where the data becomes more useful, more interoperable, more comparable. So, in summary, patchbay is basically there for individuals to be able to take control of managing their own devices, whether that's temperature sensors, thermostats, energy monitors that sit on your mantelpiece, your weather station, potentially further down the line, things to do with your health care. It's there so that communities actually together, that means groups of people, can together start to share data among themselves and hopefully improve their quality of life. At the same time, companies also use the system. For example, Current Cost, who create these energy monitors, use it basically to take their physical products and create services out of them. In other words, things that get used on again and again. And ultimately, what we want to do is sort of take advantage of the kind of efficiencies and the creativity that you get from what I call extreme connectivity. These are the kinds of things that I think make smart systems. It's the capacity to connect things together that you might not have thought needed to be connected in the first place. So, very briefly, having built this kind of back-end system, the applications that the community have built, we've built a lot of them, but also the community has just come out with libraries for pretty much every programming language. There's a wide range of things that have come out. There are visualization tools, the sort of obvious graphs and gadgets, embed in your blog your current weather station reading, or embed in your blog your current energy reading. A bunch of dashboard tools, things for controlling things over the web. They're mapping tools, tracking things both in 2D and 3D. I'll show some examples of these in a bit. There's all sorts of mashups with other services like Yahoo Pipes. Connect your Skype status to patchbay, connect a patchbay output to an SMS alert, and then every time your girlfriend comes online, you get an SMS and you know to go and find her in Skype. Somebody built an asterisk, which is a PBX system module so that you can phone in and listen to your data streams. There's converters, for example, the AMI carbon footprint converter, which will take anything that's tagged as watts or kilowatts and give you a real-time carbon footprint based on your energy provider. There's feed discovery, of course. You can search things, and the idea of being able to search sensor data or search for devices, I think, is going to be quite a big one. There are now mobile phone devices for pretty much every major phone. There's an SMS gateway. And finally, something I'm going to show you an example of in a bit is the augmented reality apps that we're actually building. So out of the box, you get these sort of graphs that you can put onto anything that's tagged in patchbay. I'm actually skeptical of graphs, but a lot of people find them very useful. And I do recognize there's a use for them in very particular cases. This was the one that we provided. Turned out that somebody wanted to have a sort of speedometer version, so they contributed that to the community. Now anything that's plugged into patchbay can use this as a dial to measure. In this case, it's measuring wind speed. There's a sort of zoomable graph down there, et cetera, et cetera. Then in terms of having like these dashboards, you got switches and dials. These can control anything over the web, whatever you decide to plug into it. Again, there's different sort of graphing. There's different sort of widgets that you can create your own website with. This is the stuff that I start to find quite interesting. Trails is a mapping gadget, which will take anything where there's a mobile geolocation, and it'll track where it's been in the last 24 hours and track one of its data streams as it's varied over those 24 hours. So on the left, you see a ship that's been measuring sea temperature, and you get an idea of what the sea temperature was at different locations. On the right, this is using the Google Earth API. This is showing a real-time search of energy monitors in the UK and showing where their current value. And so you're searching here, and you can actually see where there's bigger clusters, where the energy use is higher. At the moment, there's only a few hundred energy monitors, but you can imagine when there are thousands or perhaps even 1 million, you'd be able to do some really useful visual analysis. So augmented reality kind of applications. So augmented reality is this idea of sort of overlaying a computer-generated image onto often a mobile phone. And the idea that you might have come across is it's often used for marketing purposes. It's the idea that you stand in the street and use your mobile phone camera, and it points you to the nearest, I don't know, nearest Starbucks, and you follow the lines. Or the really useful one in London is directs you to the tube, the nearest tube. There's also a Wikipedia on Layer, which is one of the augmented reality apps. Layer, you can sort of use Wikipedia, and you can search for Wikipedia articles. We think this is going to be really useful, this idea of overlaying in real time sensor data on top of the camera image, because when you've got environments or cities full of sensor data, energy data, environmental data, you're going to need some way to quickly query it. Because at the moment, in a building that's packed full of sensors, you often have somebody wandering around with a laptop and an Excel spreadsheet looking up serial numbers and trying to figure out what serial number that one is and whether it's functional or not. And you know, it's an incredibly unscalable way of working. But if you had a mobile phone and you used our porthole application, basically you would walk in, you'd find the sensor, it would automatically identify it, and you'd know color-coded what was connected to that: carbon dioxide monitor, humidity, light, whatever. You know which one has varied the most because it's popped out further on the circle. Here you can see the real-time value in relation to its historical max and min. So carbon dioxide is roughly half. That's the brown one. And then you can press a button, you can see the actual 24-hour graph of its data over the last 24 hours. So the idea here is that you no longer need to have a sensor that's got an LCD screen on it. You can just sort of walk around and query all the sensors. Two, you don't need any kind of security system because the sensor is talking to the back end and the mobile phone is talking to the back end. You don't need any kind of communication between these two devices, which is often the security hole. Three, you can actually give different people different types of data. So a facilities manager might want really high resolution data of all the sensors, whereas somebody who works in that room might only want to know what has our weekly energy expenditure been. And so I think this is going to be quite an interesting aspect of the sort of managing sensor data. We did do a version here which where we tried to do it on the outside of a building, but the resolution was a little bit lower. And so what you see here is, if I can start that video, is basically a graph of the last 24 hours carbon footprint of the different floors. And the idea was that you'd walk down the street and you'd be able to see which are the most carbon emitted, polluting or inefficient, energy inefficient buildings on the block. But I'm going to skip a little bit of this, and I'm just going to go now to a project that's actually, this is something that my design office has built, which is built on top of the patchbay system. And it's the kind of thing that I would like to encourage, in the sense that very often these communication systems are used for coupling things, for remotely controlling things, where there's a one-to-one connection. And I think the real capacity for these networks of multiply connected devices is for them to start to take decisions that are based on neighborhoods of other devices, rather than simply saying, I click this and a light goes on the other side of the planet. It's more about these things being able to make decisions based on what all the other devices in the community are doing. And so the natural fuse is basically a plant with a power socket on it. And the idea is that the amount of power that's available to the socket is limited by the capacity of the plant through its growth to offset the carbon footprint of the power that's available. Now, the problem is that even with these 3 plants that we put into one unit, it will not offset even the carbon footprint of a low wattage LED light bulb. Actually, you need 6 units to offset the carbon footprint of a low wattage LED light bulb. So what happens is, you got one in your home, you put on the power, you say, I need power, and it wakes up and it looks out in the community. It's built on patchbay, so they're all networked together. It looks out in the community. As long as there are 5 other units out there that are not currently being used to offset energy, then your light goes on. And so the idea here is that together, these units enable the community as a whole to remain carbon neutral, because chances are there are 5 other units out there that are not currently being used to offset energy. In fact, what we do is we have a switch that says either selfless or selfish. And so if you decide to be selfless, that's good. It does what I just said. If there are 5 units out there that are not currently being used, you get your energy. If, on the other hand, there's only 3, then you might only get energy for about 20 seconds or 10 seconds, depending on what you have plugged into it. If you have a radio plugged in, you might have enough energy for an hour. That's if you're selfless. But you might choose to be selfish, because there might be an intruder in your apartment. You need that light. So you choose selfish, and you get as much energy as you need. But if you harm the carbon footprint of the community as a whole, it kills somebody else's plant. Now, this is important because what we're trying to say is that you have the choice. You can, at every stage, decide to cooperate, or you can decide not to cooperate. And certainly in certain instances, it's important for you to be able to opt out of being all nice and friendly to people. And I think it's through that kind of capacity, the capacity of these devices to enable much smarter decisions, that actually results in smarter behavior, more sustainable behavior. Now, in actual fact, what we do is we give each plant 3 lives. And so rather than actually injecting them with vinegar the first time, what happens is you get an email that says, and it's CC'd to the person who killed your plant. And you can say, hey, look, you just killed one of my, you just lost one of my lives, blah, blah, blah. And you get, it's about these social interactions that are built through the connectivity of the devices. So I'm just going to finish off with 2 slides to basically answer the question, like, why would you want to do these kinds of things? Why actually, in very practical, prosaic terms, why would you want to network together devices and environments? And I've basically come up with 7 or 8 reasons. Okay, the obvious one is to be able to remotely monitor and control them. Over the web, through a mobile phone app, what have you. This is kind of obvious. This has been done probably for about 20 years. In fact, I think there was a project in 1975 which was about sort of remote telemetry, switching something on in San Francisco from New York. Another reason you might want to do this is actually discovering these new social relationships. And I would say that the Natural Fuse project is a little bit like that. It's about discovering new interactions around our devices. It might also include, I think Alex from Tinker was going to be here. She's done a project where you buy 3 lamps and they're connected across the network, and when you go home and you switch on your lamp, then your children's lamps, if they're at college or on the other side of the world, also go on. Third reason, really practical one for companies, because you got a physical product and you turn it into a service. You have recurring revenue. You have a monthly service or a yearly service or what have you. You might, you might actually discover basically new business models. You have to start thinking about the ways you might give away the product for free, but then charge for all of the stuff that you can do with it on top of it. Another kind of practical, prosaic idea is this idea of being able to do real-time product analytics. You might send your devices out, your kettles out, your cars out, or what have you, and you'll be able to, through this connectivity, understand how they're being used, whether they're failing, whether there's any problems, perhaps even the fact that they're being used in a way that you never imagined that they would be used. Some companies come to us because they say, look, we're going to be the only ones who are connected. We'll be unique in the market. So maybe that's a good enough reason to go ahead. The stuff that I've really spoken about is this idea of the sort of cross-domain benefits of connectivity, the capacity for example, energy delivery to be based on weather station delivery, to be based on something to do with healthcare. These, I think, this is a very important part of why network devices and environments. You can also, through this kind of networking, enable other people to build applications on top of the data that you never even imagined. So, for example, if you've got an energy monitor and you're networking it, somebody else can build an SMS alert system, somebody else can do some kind of analytics of the energy data and then tell the person who's generating that data where they're wasting it or how they could be more efficient. Finally, touched on a little bit by Julian in his presentation, is this idea of making data public, which is something I support, and I think it's definitely a good thing for transparency reasons. But what really interests me is the idea of public making data, because what happens is that when you make data public, that's one thing. I'm not entirely convinced, though, that the public really understands what that data is, except through visualizations that are delivered to them. But very often visualizations serve to obscure that process of data collecting, or they can do. And so what I'm really interested in through this kind of connectivity is the capacity for the public to make data. Because when you are measuring something, when you are measuring your own temperature, when you're measuring your own environment, when you're measuring your energy use, you start to question the standards of evidence. You know, at the moment, specifically with respect to questions on climate change, we're being asked as citizens to trust the data or the interpretation or the explanation of a scientist or a politician or a religious figure or a media figure. I'm really interested in what happens when we start to measure things ourselves and really question what it is we're seeing, begin to really understand that temperature does fluctuate a hell of a lot. And even though we had a chilly summer, that doesn't mean that global warming isn't happening. And so the process of making your own data, whether or not it's really good data, whether or not it's sort of scientifically valid data, I think helps you develop the strategies, the kind of understanding for making sense of data, understanding things like dynamic range, understanding that even when you got these wonderful data sets that are collected by air pollution monitors out on the street, that somebody's massaged that a little bit because they know that this data point was an outlier, that there must have been something wrong with the sensor. Air quality monitors, which are placed usually in cities 5 meters off the ground, turns out are measuring 1,000th of the pollution at stroller height level, which is where your child might be experiencing pollution. So this idea of being able to make sense of data yourself. When you make sense of data yourself, you actually develop this capacity, I hope, to affect change. And this is where we start to take responsibility for our own environments, take responsibility for our effects on the environments, and hopefully together build a sustainable future. Thank you very much.